Okay. Side by side, the moon and Mercury. Mercury and the moon. Usually Mercury looks kind of grayish. This almost looks like it has a little bit of tan to it, kind of. Okay. But similar sizes, cooled down, similar pock marks, kind of. So I used to talk a lot more about the moon than I do now. But I guess it's just a time thing. I don't know. So on here, I kind of try to emphasize, you're used to, if you look clear over there at the right, you're used to kind of seeing the dark areas and then the light areas on the moon. Okay, and they make figures, you know, you see the man in the moon and that sort of thing. And so over there across the top now, I'm going to kind of point out how we got the light regions and the dark regions, kind of going across chronological. So it goes like this. Maybe. There. Okay. So from left to right, the left one says, all right, so you have a cratered region. Okay. Then you, the second one over says there's an impact, and with the impact, this is early in the history of the moon, when it had a little bit of ooey-gooeyness. So you can kind of see the middle slide, the ooey-gooeyness coming up. And actually, it's that liquid part of the moon that kind of filled in and gave those darker regions. We call the darker regions Maria. Okay, that's the darker regions. Okay, and they were caused from impacts and a long time ago. And like I said, the liquid part came up from the moon. And then the other part we call highlands. The light-colored parts, okay, we call highlands. So this is the highlands. I'll put H for highlands. And here are several Maria. And if you look at a moon map, they actually label the mare, and mare means sea. So you've heard of the Sea of Tranquility? That's a mare. Okay, mare tranquility or something like that. Okay. And in the highlands, everything's labeled. Yeah. So switching gears, and the rest of the chapter just kind of talks about objects, okay, terrestrial-like objects, and it just struck me this semester that it started with the smallest, the moon, then it goes Mercury, then it goes Mars, and then it goes Venus. Okay, so yeah. One of the things, and I can't remember if it's a homework question or not this semester, but oh, maybe not. I'll go to the next one. Well, I know it made it to your test review sheet. So one of the features on Little Mercury is called the Caloris Basin. And so the Caloris Basin is basically just an impact crater, okay, kind of over here-ish. And then what you will read is that the region, so if the Caloris Basin is right here, okay, the region directly opposite the Caloris Basin on Mercury is all kind of jumbled up. So basically, it's like a shock wave went through the planet, okay, with that one impact. They're pretty cool. So one of the features on Mercury are these scarps, S-C-A-R-P-S, and it's an indication of when it cooled. It basically, well, you know, when concrete, the reason that when they make a sidewalk, they put breaks in the concrete is so that the concrete can swell when it's hot and shrink when it's cool without, you know, breaking. So actually when the same deal when Mercury cooled down, it contracted and created these kind of cliffs called scarps. Not a stretch, is it? Okay, so Moon, Mercury, Mars with regard to size. So, you know, if you're like me, before I kind of dived into a little bit more what's up with the planets, I would think Mars was more of a sister planet to most like a sister planet to the Earth. But as it turns out, Venus is more similar in size and all that. Mars is a fair bit smaller than the Earth. It's located 1.5 times from the Sun. as the Earth. And its axis of rotation is tilted similar to the Earth, though. And so actually Mars has seasons. And we can see kind of it's got ice caps, okay, but the caps, the ice caps on Mars are not water, they're actually dry ice, they're actually carbon dioxide. So Mars, since it's so small, it really doesn't have much of an atmosphere. Okay, so it's pretty cold on Mars. Okay, so there's Mars, tilted axis of rotation. And this slide emphasizes that, that it's a little more eccentric, its orbit, than the Earth's orbit. And so that perihelion and aphelion are more exaggerated. Does that kind of over there on the right, doesn't that look like it's closer? Okay, so we would call that perihelion. Okay, and so what this is saying is that the summer in the southern hemisphere is a little bit warmer than summer in the northern hemisphere. Does that make sense? Okay, and here this is aphelion. Seasons on Mars are more extreme in the southern hemisphere. So it is cold in here. Yeah. Feel free to get up and move around. So there's the dry ice down there at the bottom. You can kind of see the whitish. But the other thing, do you see where this looks all like hazy compared to this? This actually, you can see the surface more over here than you can over here. And the reason is dust is being thrown up into the atmosphere of Mars. So this is a look at the surface of Mars. Just kind of, there are, I mentioned the rovers tonight. You know, the latest one is Opportunity, the rover. You know, we saw what he or she did in a year. But there's all sorts of satellites orbiting Mars. You know, and India and India and NASA both sent one like within the last couple of weeks. They arrived in the last couple of weeks. But they are great at taking satellite images like this. So Mars has craters. You can kind of see the craters, but they're different. Dust storms that we saw, kind of an aerial view of the planet when it had a major dust storm going on. Can you almost kind of see the dust erosion maybe with these craters? Yeah. This kind of reminds me, there was, and I don't think I included it in my lectures this semester, but there's a controversial, like, have you ever seen The Martian? This was like in 1970 where it looked like a sphinx. The head of a sphinx coming out of the Martian surface. Like, anyway. But then, like, some dust blew around, and they went and looked at it, like, maybe 20 years later, it wasn't there. I just think that's interesting. So, busy place, right? Actually, not all of these are spacecraft. Let's see. You see the Phoenix landing site, Pathfinder landing site, Viking. Viking was an exciting little mission back in the 70s. Viking 1 and 2. We'll talk about them more, but do you remember I told you that there's a big boo-boo? Maybe I didn't actually. I kind of get my review session mixed up with my lecture. But Valles Marineris is like a big old trench kind of along the equator of Mars. And Olympus Mons is a big volcano. Okay, kind of a dormant volcano.
Didn't they send something up there to specifically look at that Olympus?
Olympus Mons, it could be.
I said something in the book that it was to look it up and see if it had landed yet.
Okay.
Yeah, I actually said that in the book.
That's neat.
That it was.
It's on its way?
Specifically for that. Yeah, I think it landed. I just did a quick search.
Mm-hmm.
But it doesn't say much after that, so maybe it's still looking.
Yeah, I can't remember the targets. That might be a target of that, the cute little curiosity. I don't know. There's that volcano, Olympus Mons, is like humongous. And they call it not a volcano, but what's left is called the caldera. And actually, volcanoes on Earth leave caldera too. Caldera is kind of just like you almost, if you're in a caldera, you don't know you're in a volcano. It's because it's just kind of like the top is blown off. That's kind of what I think of. Okay. And then I just added, it's kind of like the Grand Canyon of Mars. It's called Valles Marineris. And I can't remember if I have an individual slide or if I just kind of wanted you to get. So there's how you spell Valles Marineris, and there's Olympus Mons, but you probably can't see mine. Cute.
Very, very tiny.
It is very, very tiny. Okay. It's so cute. Okay. So, Spirit and Opportunity were kind of like sisters. They went up within a year of each other, I think. Very similar rovers. And the thing NASA, I think, is known for is things like these rovers, they very much outlast when the engineers say they should quit function, which is good. It's kind of like they underpromise and overdeliver. Okay, but with that said, Spirit, and it's kind of, if you watch the scientists explain kind of the saga of these rovers on Mars. Spirit stopped functioning, gosh, maybe it was 3-4 years ago, in kind of a sad sort of thing. It got stuck. Its little wheels got stuck. And I think it needed to move somewhere where the sun was so it could get energy, fill its solar panels, use its solar panels to fill itself with energy. And it basically got at a location where it's never going to wake up again. That's sad, that's Spirit. But Opportunity is still roaming around. And now there's Curiosity on there. So, I know. So Opportunity sent these pictures back, kind of a close-up of a little nodule-looking thing clear there on the right. And if you understand things about rocks, that actually is an indication of flowing water. Okay, or liquid water, I guess I should say. It looks very similar to kind of Earth. I don't know, kind of creepy. So with regard to water, Mars has it, but it's generally tied up in its solid state. The bottom set of pictures are kind of showing you a close-up of kind of, it looks like how water would have just kind of gushed and flowed, creating that kind of erosion pattern. But I've even heard that, and I didn't hear it knocked down, so nobody discounted it, but that rovers have actually caught the evidence of flowing water now. So, okay. So like that slide said a few slides ago, we think Mars used to be a lot warmer and wetter than it is now. So why is it not the way it used to be? So this is a picture of early Mars, and the pink is kind of like we have the pink. The pink is representing that protective magnetosphere. And of course the yellow is the sun's solar wind. See, the thing though is that probably when it had a magnetosphere, it did go ahead and have an atmosphere to keep it warm. Okay. But now, Mars today, notice the pink lines are not there. Of course, the sun is still sending solar wind. And so, kind of to talk you through how it lost how we went from early Mars to today's Mars without a magnetosphere, okay, and without an atmosphere. Basically, you notice the bottom it talks about cooling. We said that Mars, since it's so small, cooled a lot faster, okay, than the Earth. Okay, so when it cooled down, basically it lost its magnetic field, okay, and when it lost its magnetic field, it left its atmosphere vulnerable to solar wind. Okay, so that's kind of how you kind of summarize where we got today with Mars. All right. So, Venus, geologically active? We think so, but it has kind of a strange geological activity. It's possible. It seems like it should be kind of ooey gooey because its cooling rate should be similar to the Earth because it's a similar size. The pictures I'm going to show you of the topography of Venus, actually, we can't see through Venus's thick clouds in general to get these pictures. So pictures like this, topography has been taken, I'll just write it down here, using radar. Topography, and this is on the test, taken. So when I say topography, I'm kind of talking about terrain. Using radar gun, using radar. And when I say radar, basically they have a spacecraft that orbits the planet. It sends down a beam of radio waves and it looks for the reflectivity. And so it can get a sense for what the terrain is. Okay. Topography is kind of like the terrain. Like, is it bumpy or does it have a volcano? They can map that stuff. Okay, so we definitely see, we don't see them, but we can tell they're there, volcanoes on Venus. There's been one spacecraft that landed on Venus. One cute little Russian spacecraft.
But it burned up.
What's that?
It burned up, didn't it? It got too hot.
After it landed, maybe, because it sent back a few pictures, but I think it was rough. Yeah. And from radar images, you know, we can tell it's got, looks like it has, like, where plates could be, plate boundaries.
It just looks so much like the sun. It's just like based on those pictures.
Yeah, it does. The color makes it look like the sun and kind of the texture.
Yeah.
I agree. Totally. So this is like the cute little leg of the spacecraft, excuse me, that landed. And like I said, it's a Viking mission that not a Viking mission, sorry. Viking landed on Mars. This is Venus. It is a Soviet Union spacecraft, which I may not be able to recognize.
And they haven't tried to land another one?
I know.
Because that was like 20 years ago, wasn't it? 25 years ago?
Mm-hmm. Makes you wonder.
A lot of money.
A lot of money, yeah.
That's true. And if it's just going to not last very long, I guess.
Yeah, but how cool would that be, you know? I mean, I'm with you there.
I know. I know this about Mars and all this. But
Let's
I
go.
know about Venus
No
now.
traffic jam. No waiting. So with regard to Venus being geologically active or having tectonics, we think probably it does because its cooling rate should be similar to the Earth. But it looks like it doesn't have kind of the whole like earthquake sort of slabs moving around. But it looks like it just gets really hot and then all at once it melts. So it basically builds up heat for a long time being 750 million years or so. I know. Then all at once, basically, its crust just kind of melts and it resurfaces itself.
Wow.
I know. So Venus is very hot. I think we looked at and saw that its daytime and nighttime temperature are very similar, unlike Mercury, which it's got a very sharp difference in its daytime and nighttime difference. And it's very hot because of its thick clouds, which are carbon dioxide. well, its clouds aren't carbon dioxide, but it's got a lot of carbon dioxide in its atmosphere. So instead of mostly being nitrogen, like Earth's atmosphere, nitrogen gas, it's mostly carbon dioxide. So if you were to stand on Venus, instead of, you know how like we have, I know, like when you go swimming, you feel a different pressure, okay? And like if you were to go down in the ocean, you would feel a different pressure, okay? Kind of along those lines, if you were to stand on Venus, you would stand, instead of like what called one atmosphere, you would have 90 atmospheres of pressure on you. Okay, so that would be terrible. It would crush you, yeah. It would crush the bones as we are now. Yes. Okay, so strong greenhouse effect because of the carbon dioxide. It's a great at redirecting thermal energy that would try to escape Venus. Oh, I know. This goes on to say that perhaps, let's see. Oh, so carbon on the Earth wasn't as much in the form of gaseous carbon dioxide, but carbon actually has found a home on the Earth in our rocks and is dissolved in our oceans and tied up in our little crustaceans. So when we look at Venus, okay, I'm hoping you kind of think of this sort of cloudy looking thing. And those clouds actually, it rains, but it rains sulfuric acid instead of water. It's problematic. Okay.
So it doesn't escape the atmosphere, and that's why it stays so hot? Like, you know, some leaves our atmosphere,
You mean the heat doesn't
Yeah.
escape the atmosphere? Yeah,
Yeah.
yeah.
and that's why it's so hot on
Mhm.
Venus.
Yep. Exactly. And so kind of related to the greenhouse effect and being so hot. This says if we were to relocate Earth, where is it? There it is. And move it to where Venus is. Where's my thing? We would have issues too. I don't know. Okay. So let's go do a few slides in the gaseous planets, shall we? We shall. Oh, maybe so.
That's so pretty.
It's gorgeous. Mm-hmm.
I really like the planets with the rings.
You really like what?
I like the rings around the planets.
Mm-hmm.
I think it's because on our first lab, we actually got to see the rings around Saturn. And ever since then, I'm just like, oh, I think about the rings.
Outstanding, yeah. I agree. Beautiful, beautiful rings. So, see the gaseous planets all together with the Earth kind of drawn to scale up there. And here they are listed from their proximity to the Sun from left to right. We kind of have pairs of them. Jupiter, Saturn kind of go together. Uranus, Neptune kind of go together.
Why don't they show the rings on us? The rest of them? Don't they all have rings?
They all have rings, yeah. I don't know. I think the especially like they're wispy. They're not as predominant,
Oh, okay.
but they're there. So Saturn and Jupiter or Jupiter and Saturn are mostly hydrogen and helium, and then with the blue planets, we kind of pick up some of the hydrogen-containing compounds. Remember we talked about the 4 different types of stuff in our solar nebula? Hydrogen and helium was most abundant, and then the hydrogen-containing compounds. So frost line, remember the frost line in chapter 6 we talked about kind of divides the rocky planets from the gaseous planets, the terrestrials from the Jovians. And so colder than the frost line, we could go ahead and get those hydrogen-containing compounds to go ahead and begin coming out of being a gas. Okay, and so they got larger, and then actually they got large enough to go ahead and keep gases gravitationally bound to them, hydrogen and helium. So this is kind of interesting. The cores of all those, the cores at the middle of all those gaseous planets are kind of little rocky terrestrial planets. It's like they swallowed a rocky planet. Okay. So Jupiter and Saturn are mostly hydrogen and helium, but why are Jupiter and Saturn like that? And the blue ones, Uranus and Neptune, why don't they have as much hydrogen and helium? And it kind of comes into timing and location. And if you, now I didn't grow up in a big family, but here tell, if you grow up in a big family that's aggressive at supper time, you might relate to this, I don't know. So if you're there on time where all the food is, you're more likely to go ahead and get enough to feel full, okay? And if you're sitting by where the food is being passed out, you're more likely to also succeed at getting full. If you're not there on time and you're not in the right location, you might go away hungry. So along those lines, the planets that formed earlier were more likely to get larger. So honestly, you're looking at Jupiter and Saturn forming earlier. And as far as where stuff was that accretion could go ahead and make these planets larger and larger, closer to the sun had more stuff too. Denser part of the solar nebula. So this kind of gets away from size and starts to talk about density. So density is how fluffy something is. Like if something's really dense, then, and when we talk about black holes, okay, we're going to talk about something really dense. Okay, so basically, when I talk about density, oftentimes I think of taking at Christmas time, you have a bunch of wrapping paper, and you have one trash bag. And really, you should have 3 trash bags for all the wrapping paper you have to get rid of. So what do? You just kind of stomp it in there. Okay? So as you stomp more and more and more, the density increases in your trash bag. So density increases is kind of how that goes. So notice actually then that Jupiter is more dense, more packed than Saturn. Saturn's fluffier. Now the cool thing about the number 1 there is that's the density of water. So right here, that's the density of water. So anything that is more dense than water would sink, and anything that's less dense than water would float. So that's to say that if you had a big enough bathtub of water, Saturn would just float. Isn't that wonderful? Okay, so Jupiter is more dense than Saturn. We kind of have to address that a little bit. We think that Uranus and Neptune are more dense just because, remember, they have those hydrogen-containing compounds, which is going to be more dense than hydrogen and helium. So Jupiter got more packed, compact, kind of like this, where if you keep adding pillows, even though the pillows are all fluffy, the pillow on the bottom is going to get squished. And so even though hydrogen and helium is really fluffy, if you keep adding it on, it's going to create a dense situation. Okay, so that's kind of why we think that with regard to Jupiter, Jupiter is more dense than Saturn. Okay, so kind of side by side we have the pairs of gaseous planets, Jupiter and Saturn, and Uranus, Neptune, kind of like we looked at the terrestrial planets with the core, the mantle, the lithosphere, and the crust. But we got some interesting terms here. Now, I've heard of hydrogen, right? You've heard of hydrogen, and hydrogen's a gas. But here we have hydrogen being a liquid and hydrogen kind of behaving as a metal. And that happens, quite frankly, just because of the extreme pressures that hydrogen is experiencing in the near the cores of the planets. Okay. So we have visible clouds. That's the pretty kind of swirly stuff we see. We have gaseous hydrogen, liquid hydrogen, metallic hydrogen, and here in the middle are where they basically swallowed a terrestrial planet. these pairs of planets, notice that they are missing a few layers. They don't have the liquid and metallic hydrogen, okay, but they also swallowed a rocky planet. So you can't stand on these gaseous planets. You can't stand on Jupiter, Saturn, Uranus, or Neptune, okay? So why do they have different layers? Dot, dot, dot. So I mentioned liquid hydrogen and metallic hydrogen. It has to do, it's related to their extreme pressures and actually temperatures. So, let's see, we're about, let me go back. So these are some crazy pressures as you get closer to the center of the planet. Notice here is kind of a drawn to scale of the cute little Earth. I don't have a whole lot to add. This didn't make it to the test, so I'm not too worried about it. My dogs will not be happy, but they don't like storms. Dogs don't.
Mine are fine with it.
That's good.
Yeah. I
Go.
sleep through it.
I feel bad for them. So, I mentioned that Uranus and Neptune don't have the liquid and metallic hydrogen because they don't have the pressures that can create it.
They don't,
Okay.
say that again?
Because they don't have you increase pressure as you go towards the core of those planets too, but you don't have all that pressure that you have in Jupiter and Saturn. Well, do you recognize the kind of ghosty looking thing over there at the left? The magnetic field? Okay. The Earth's magnetosphere? Well, the gaseous planets also have a magnetic field or magnetosphere. Okay. And theirs is, if this is drawn to scale, and that tiny little dot in there is the planet Jupiter, which is humongous. Can you gotta get a sense for its magnetosphere, how big that is? So this over here, these are the northern lights of, these are auroras, where charged particles are falling through Jupiter's atmosphere.
So Jupiter has a magnetic field.
Jupiter has a magnetic field. And all of the gaseous planets have magnetic fields. Jupiter rotates really fast, like once in 10 hours it rotates. So, I'm going to talk more about what this is. I think this is a great red spot. But so Jupiter's atmosphere, excuse me, as you fall through its clouds, it gets, as you fall through its clouds, it gets warmer. I was like, really? Yeah. It's coldest at the top of the clouds, and it gets warmer as you fall towards the surface of the planet. And so you kind of hit these layers of what temperature things will condense. So you have ammonia, then ammonium sulfide, ammonium hydrogen sulfide, then you have water. Kind of gives you your different colors. Pretty. So, it's hard to miss, right? These beautiful, this is called a white oval, okay? And this, I think, is the great red spot. In the meantime, you can see all sorts of swirlies. And sometimes these ovals will join to make bigger ovals. They're like little storm systems in the clouds of Jupiter. What's that? Mm-hmm. You're fine.
And this is the planet that has the one big storm that's just been
keeps building.
Mm-hmm. It is the one, it's got a great red spot. Mm-hmm. So, Jupiter and Saturn look kind of similar. And actually Saturn has kind of striations, stripes to it too. Usually we only think of Jupiter, but it definitely has stripes. Like a little more subdued. Yes, I can. Oh, you got that. Okay. You can find me some coffee. Okay. What?
It said methane.
Methane, we were right. So the formula for methane is that CH4 carbon, one carbon atom and 4 hydrogen atoms. Okay, make methane. And that is, and cows make methane. And that actually is what makes these planets appear blue. There's so much more to say about the planets than these slides. Oh, that's just kind of the way it goes. I thought I had a slide in here. It's like going back and forth between the planets. Yep. So Jupiter's great red spot is shown here. And if you're like a weather junkie, you've seen weather maps that have these H's, and an H on a weather map stands for a high pressure, kind of a central high pressure. And so there is this thing called, weather associated with the planets. So it's kind of interesting to think. But the thing about Jupiter's great red spot, is this going to take me out? I think it will. Is that it has been diminishing. The guy who first saw it 300 plus years ago, it had stayed a similar size for all that time, and now it's shrinking just a little bit. We'll see. Okay, so in general, if somebody asks you what's the weather like on one of those Jovian planets, you can just say stormy with lots of wind. So here's kind of a close-up of Jupiter, Saturn, Uranus, the side-tipped one, right, and Neptune. And you can see Neptune, that arrow's pointing to kind of a blotchy area of Neptune. I think they call that the great dark spot. But it didn't last as long as, I think it's gone now. The great red spot. So if we were going to go visit something and explore something, we really can't put a spacecraft on a gaseous planet. It's just not going to work. But we can put a spacecraft on one of its moons. And honestly, scientists are more excited, or are excited about the possibility of finding life on one of these moons. Okay, these are the moons that Galileo saw. So kind of closest from Jupiter going out, you see Io, Europa, Ganymede, and Callisto. Very pretty. So in general, moons can have that ooey-gooeyness in them. Moons can be geologically active. The larger the moon, the more likely it is to be geologically active, because it can retain its heat. The smaller the moon, it's just a rock. No offense, but. So kind of look like small moons. Yeah, kind of look like potatoes, that moons that Mars has. Phobos and Deimos.
Oh, I was listening to you.
So kind of what makes them so irregularly shaped, like this says, is if they're, the thing that makes, let's put it this way, the thing that kind of gives objects roundedness is size and time. So size for gravity to kind of kick in, and time for gravity to kind of round the edges. So here we have the gaseous planets, Jupiter, Saturn, Uranus, Neptune, okay? And you see kind of an assortment of their moons. Now that's not all the moons that they have, just kind of an assortment of their moons. Kind of some of their famous moons. And what we see on a lot of these moons that orbit these gaseous planets is that they have a lot of ice. They're almost like a kind of a comet that the edges, they become round, okay? Another thing is that, that last bullet up there, a lot of these moons are pretty big, spherical, and they orbit in the same direction that the planet spins. Okay, so the planets are all rotating on their axes, and the moons are orbiting and spinning. Okay, so it's all kind of like the conservation of momentum, the spin you would think they would be. Oops, wrong way. So, starting with the moons that Galileo saw. Or should we take a break? Thank you. Yeah, let's take a break, and we aren't going to be here all that long after this, but I want to take a break. Okay? Yeah, stretch your legs.
And go out there, because it's warmer. Yeah.